Hello everyone again and welcome to this particular video, and in here we're going to be exploring sets. And some of you might be wondering, what is set all about? How are we going to explore these in terms of data management? And this is going to be important and crucial because you need to first be able to know various theories that are associated with this particular concept, sets. And before we talk about this, we need to have a definition about sets. Set is known to be a collection, collection of objects. Any collection of objects that you have either around you or in your surroundings or environment, we are going to consider that as generally sets. So let's say, for example, I have a specific diagram here and we have some interesting objects. We have this object that is particular symbol, and we have another one right here. We have another object like this, and let's say we got this occurring many times as much as possible, and let's say we have an extra of this particular object right there. So all these here, they are in a set, and when we say that they are all in this case here, a set, it means that whenever you have a container and the content inside it is defined, then it means that that container itself is a set. Now, on the other hand, we have a particular component that is needed for a set, and this component here is called the element, and the element here is considered to be an object that is in a set. And so an example of element as we defined here is this particular object inside, which we consider it to be an element because this element is contained in a set. And so there are other specific objects in this particular set. We have this circle right here, we have this rectangle or square, we have another object which is a kite looking shape, and all these are defined as elements. Now, there are other great examples of considering sets. There is every capital letter that you see in this particular state here. Like for example, S is an element here of capital letters, and this other object here, which is T, is considered to be an element in this particular capital letters. Another one here is cars with plate number that is written as Ontario. So when cars are passing by, we do have plate numbers that you see either at the front or behind the car. So my drawing is not the best in the world, but the plate number here, when you zoom at it, you should see some specific symbols and also text. One is the city where that particular plate number is issued, in this case here Ontario, and we have a couple of number combination with alphabets. Whatever number that you have here, you can say all cars with the number 1, so you find all those cars, all cars with the label assigned as Ontario. That is another one that you should watch out for. So that's what it means in this case in terms of set of cars with plate number Ontario. And the other one here is set is, in this case, when we are defining sets, we need to recognize that when choosing set, we should try to be unambiguously defined. And what does this particular term truly mean? It's quite a specific definition here. Unambiguously defined. Why is it has to be? Because there are so many cases where we tend to make general assumptions, and those assumptions are not clearly defined, and avoiding those is truly crucial here because we don't want to sound really stereotypical, or in this case sound really discriminatory in terms of categorizing objects or peoples or characteristics. So let's say, for example, saying that in this case all great soccer players could be divisive in a way because it is really meant to be subjective. this is actually a subjective term to say that all players are great, or calling all great soccer players. One person might call that as, oh, I don't think that player is actually great. That person might be good, but a different person might see that same player as a great player. So that is truly not defined in this particular case right here. Another one here is likable characters in a movie. There are some cases where you might have a movie where people love this particular actor or character, but some people might not really. So it's not a unifying concept that is clearly defined. So therefore, we need to try to avoid situations like this when it comes to creating sets. That is something you should keep in mind. So now we have that taken care of, we need to be able to now look at another segment of this particular set theory where we need to look at set notations. And so set notations is quite crucial because we need to be able to start from somewhere and use that as our foundation for future videos to come. So in this case here, we have set notations. And so set notations here, we're going to look at in total 4 notations. And the first one here, when we are looking at this particular case scenario, which is having our specific set, and in our set we have these particular types of elements. Don't forget that, get familiar with those words. Elements in our set, we have this, we have circle, we have a kite, we have a squiggly object, and we have the final one, which is a particular square. So case scenario number 1 is, first we need to be able to clearly define what it means when someone says an object, which is in this case, we can say any object which is S is an element of or in set A. So what does this actually mean? How can we transform this into set notations? Now, one key term here to keep in mind is called element. An element is expressed as the symbol E, and this symbol here is going to be applied to this whole text that is seen right here. And this whole text is going to be written now in terms of the element E as X is an element which is expressed as this symbol in set A. So therefore, in this case, we are able to now express these words in or sentence in notation form for set. So an example in this case will be that in this particular diagram, as we see over here, X could be, in this case, expressed as this particular object, this particular object, this particular object, this particular object, or this particular object. So therefore, in this case, we can say that any of these particular symbols are elements in A. So that's something to keep in mind. Now, the opposite of this is where we have a particular case scenario in which we have X is not an element in set A. And so what do you think the opposite of something will be symbolized as? Make your guesses, and you should come up with what I have right here, which is just having a stroke line across the original true symbol, and that is an indication that yes, X showing the symbol is shown to be not an element in set A, as is going to be revealed right here. So X is therefore not an element in symbol A. So an example of this will be where we have, any other symbol that someone might ask you. Let's say, for example, someone might tell you that, hey, is a cylinder in this particular symbol right above here? No. So in this case, cylinder, which is represented as X, we can just write it there, is not an element in this particular set of A, which I'm drawing based on this particular set A. So in this case, we're defining set A to be this particular object that we have that is a container. And so in this case here, that is what we're doing right there. So there are other great examples of expressing this in terms of numbers. When looking at elements, we can say, for example, for a number to be an element of a set of a specific category, we can say that, hey, how about square root of 3? So square root of 3, how can we make that into a set category? So we can say, in this case, square root of 3 is an element of a set of real numbers. And yes, square root of 3 is a real number, and so therefore it is a set of real number element in a set of real numbers. Now, this other part where in this case we need to find a different category for A, we need to be able to look at how we can make square root of 3 to not be a category. And to do that, all we have to do is just think about how square root of 3 is looked at and based on how we can create rational and irrational numbers. And from what we can gather here, it is not a rational number. So therefore, square root of 3 is not an element the set of rational number. But you could say at the first case here that square root of 3 is an element set of irrational numbers, and that will be the opposite of what we have right here. Now we have that taken care of. We have the next one where we need to be able to have one additional symbol that is called braces. And some of you might be wondering, what is braces? Is this something that we put in our teeth, and stuff like that? Braces, not really in this case with respect to sets. In this case, it is used to bring things together when dealing with sets. And it is indeed a symbol. And you're wondering, what is the symbol like? The symbol is pretty much this little bracket that has this little twist at the middle on both brackets, and this is used to represent sets. And wherever you have anything in a set in terms of where they are contained, like for example in our case that we have here, we have not only this particular object in set A, but we also have circle, and we have kite, we have square, and looking above here we have squiggy object right there. So therefore in this part we have a specific term to be expressed as the set shown as this particular symbol right there. So in conclusion, brace is actually another way of expressing set. So let's look at how we can apply brace to various case scenarios. So we're going to divide this into two parts, where on one side we're going to look at brace in terms of just applying our understanding of infinite sets. Like for example, we have these numbers given, and you're asking yourself, how are these numbers going to be categorized as a specific category? And so using the brace and these numbers, what you notice is that these numbers do look like something familiar. 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and so on. So this shows an infinite series here, mainly due to the dot 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 that is shown at the end, but also this bracket that you see here with the twisted edges shows that they are sets. And so therefore, in this case, we can conclude that these are sets of powers of 2, and that is how you're able to express this. Now in this case here, when we are expressing brace in terms of infinite sets, let's look at the other case. And the other case here is looking at brace just in terms of elements of sets, and in this case looking at brace in terms of elements of set. We have a great example where we have, hey, 5 is an element of what can you create for an infinite system? We can say that yes, 5 is an integer, and integer indeed is a set, and this set here is expressed as this bracket with the twisted ends for a specific category. Another one here is square root of 3, and in this case, is it or is it not an integer? And you all should have the answer, which is it is not an element of integers, and so therefore set of integers. So that is how you're able to express brace in terms of element of set. So now we have that taken care of in terms of brace. We're going to look at our final symbol, which is in terms of set defined by property. So this fourth and final one for this particular video is where we're going to be able to look at how set defined, in this case, by a property. And so how can we look at properties? Now this here all comes down to looking at how we can bring up an example and try to illustrate what it means. Now an example will be, in this case, when someone says set of all variable or a specific object where P, which is in this case a property, holds, this can be expressed by a symbol first, which is shown to be as follows. We have this particular bracket, which twisted symbolizes that these are sets where X is a property that is held by P. Now, in terms of how we can apply this symbol to a specific question, a question might come up in this particular format, which is as follows. A set of all numbers that is greater than 5. Now this here might be a little bit troubling in terms of how to express this in a symbol form, and so using symbol format based on what we have right here is that we need to just first look at the property that we are focusing on. So the property we are looking at here is number greater than 5. So in this case, X you can pick as a variable of the numbers or series of numbers that is greater than 5. And so X could be, in this case, 6, X could be 7, 20, 1 million, as long as X is not 2 or 3, no, or 5, because if 5 is not greater than 5, 5 is equal to 5, but in this statement here, we want only numbers that are greater than 5 and not equal to 5. So this is a way for we to express sets of all numbers, which is usually expressed as x, that is greater than 5, which is what we have right here. So that is something to keep in mind. Now, take note that if you want to have any drawing that will be used to express this in terms of visuals, I kind of created this where we have this particular container which represents our set, and then looking at it visually, instead of you writing 10, 20, 40, all you just do is draw a straight line, and at the end of this line you have positive integer, that is infinity, sorry, and then you start at 5 here, and we make a circle which symbolizes that 5 is not included, and or donut, and you draw a line to the right which shows that yes, you're looking at the x values that are greater than 5. So that is one particular case example. Another example here is where someone says that, hey, we have another case scenario where we have a set of all numbers that is focusing on a square greater than the number 16. So now changing this into symbols is another big one here that we need to address. And so to address the symbol representation, first we need to look at the all numbers. So all numbers is represented as x, and it says here that whose square, that means the square of that number, is greater than, in this case, 16. And so therefore we are able to express that set that is told in here. And so therefore this is a great example of how to address a word problem and transforming it into symbols representing sets. And so this here, an example as shown above here, is in this case we have a container, and inside the container, instead of writing all the numbers for x, that is where its square is giving us a result that is greater than 16, all we just do is draw a straight line. We know that is greater than a number, so that means we're going to positive infinity. Therefore, for our x value, which is what we are looking at here, that x value must be somewhere around here, where our x must be, when given the square, must be greater than 16. So therefore x must be 4, because 4 squared is 16. But take note here that 4 is not included, because in this case we have not defined our greater than to be equal as well. So in this case here, we are able to define this particular sentence in terms of the symbol and also a diagram to support our argument. And so, in conclusion of our time together in this particular series of videos, what are the takeaways? The takeaways here is as follows. We're able to generate specific symbols that will be important in terms of our understanding of sets. One is involving, in this case, object. What does that symbolize? This symbolizes x, or any form of a variable of your choice. So a variable of your choice, it comes handy when it comes to an object. Now, when we are asked about a set, in this case here, we used capital letter A, or you can use any container or any variable that is a capital letter variable. Usually there are other cases where you might use something else, but you are required to define that for yourself, or using categories, or most importantly using braces. So that is something to keep in mind. And next here is, when I say element, what does that actually look like, or how does it look like? All you have to do is just have this E, and that is it. Take note that it doesn't have any other thing outside of that E. And finally here is when it says that not an element. How is that shown? This is shown as the E with the stroke line that cuts across through it. So that is all the necessary things to keep in mind